Hello everyone, in this video I'll be explaining you the problem minimum sensors to cover grid. So this was asked in LeetCode contest, it was bi-weekly contest 163. So let's read out the problem. You are given n cross m grid and an integer k. A sensor placed on cell R, C covers all cells whose Chebyshev distance from R, C is at most k. The Chebyshev distance between two cells R1 comma C1 R2 comma C2 is maximum of R1 minus R2 modulus of this and modulus of C1 minus C2. So your task is to return the minimum number of sensors required to cover all cells to cover every cells of the grid. Okay. So yeah, let's understand example. They have given n is equal to 5, m is equal to 5, k equals to 1. So it's easy only. It's basically greedy approach. So what they're saying is they will give n comma m in which we'll have to find the grid n comma n cross m, like basically nm is the grid of size n cross m, and what they're saying is some Chebyshev distance, some distance. This distance is given by let's say we have one point here and we have one point here, and this point is r1 comma c1. R1 is basically rho 1 and this point is R2 comma C2. So the distance between these 2 points is given by max of modulus of R1 minus R2 comma C1 minus C2. So this is the distance that they are saying. So in this is the distance shaped by distance. So let me call some x distance. I don't know how to pronounce this name. So actually you'll have to find the distance between what? Distance between centers. Initially in the grid we don't have any sensors. So for given example, n is equal to 5 and m is equal to 5 and k is equals to 1. So what they're saying is this sensor, let me tell you the meaning of k here now. So meaning of k here is that if you place sensor, let's say at this position, so it can sense up to a distance of k units, okay, either upward, downward, left, right, diagonal, something like that. So that distance is basically given by this x distance, okay. So for a given example, let's say n is 5, m is 5. Let me draw. So we have a 5 cross 5 matrix, it is looking. So what they're saying is, let's say if I place sensor here, okay, one sensor at this position, so now it will cover a distance up to if you take this let me take indices as well. This is 0 1 2 3 4th rows, 0 1 2 3 4 columns, so column numbers are there. So this point u is given by r1 comma c1 and which is basically 1 comma 1, right? And let me take one sensor like, okay, if we place this sensor, so what all distance it can cover, like till what all distance it senses it can sense any basically sensor is to sense things, right? So till what all distance it can sense. So now, so you'll have to they've given it can sense up to k is equal to 1, distance k is equal to 1. And if you try to put, let's say this one which is 0 comma 1, you have, let's say, r2 comma c2 as 0 comma 1, and if you try to find its distance, let me call cd, it is some name, Chebyshev by distance, and it is given by r1 minus r2 and its absolute value which is 1, and this is 0, so max of that is 1. So at this point a distance is 1. If you like, this sensor can sense here as well, right? Okay, so you don't need to place sensor at this position. The other sensor, basically you'll have to place minimum number of sensors such that it within all the cells in this grid must be within range of one or other sensors. So this particular sensor can sense this. Let us try to sense this one. It is 0 comma 0. So R2 is basically 0 comma 0, and its distance is 1 minus 0, 1 minus 0, which is 1, and max of that is 1. So it can sense this as well. So this is also in this census range. So it will also be in this census range, like if you try to do it. So one census you have placed here. Let me try to if you try to put I mean do these things distance, so you will come to know that this sensor covers this all ranges. How do we say that? Because we do it by r1 minus r2 using this distance. But one more catch is that since k is 1, from the present sensor, like sensor at which location is present, it will cover till its that much k distance. Since k is 1, so if you go from this cell to this cell, your distance is 1, so this is covered. And if you go diagonally as well, since distance is max of r1 minus r2, so it will be like rows difference and column distance, which is the maximum. So diagonal will also be coming to this only. Row maximum is here 1 and column maximum is also 1, because row is one distance away and column is also one distance away. So if you take if it was like something sum of these two, then it would have been here like this is not covered within this answer. But since it is max of these two, so it is covering. So basically in all directions, one distance you can go. You can go one distance up, one distance in this diagonal, one distance right, one distance in this diagonal. So from the given place of the sensor, you can cover one distance in all directions. Now what if you place can we have sensing of this sensor at this location and this location, if you see, that is 1 comma 3. So let me write here 1 comma 3. Now if you try to take distance, 1 minus 1 is 0 and 1 minus 3 is 2, so maximum of 0 comma 2 is 2. But they are saying your sensor can sense up to only maximum of one distance, so here distance is 2. So at this position, this sensor's uh, area is not coming. It cannot sense this area, this sensor. So now since it has covered this much, try to put here one more sensor. Why you want to put here one more sensor? Because again, if you put at this position greedily, so it can cover its this range. If you put here let's say, and you have one more column, let me try to explain that way. So it will sense only one distance, but here it is not sensing. But what if you place here? If you have placed your sensor at this position, so it can cover all this distance. So that's why greedily what we will be doing is, we will be basically taking one distance, k is not 1 here, k is 1, that's I'm taking k distance from the column and try to put it. Okay. So we'll have to take 1k distance at this position, and downwards also we have to take this, because whenever you put sensor, it can cover up to k distance. So that's why you will have to go row wise k down distance and column wise k down distance, so it can cover this much area. Now you think of this is my starting point, and again same thing I'll do. Okay, like I'll go to k distance downward, k distance to column side, so you can place here. So now this area is covered by this sensor. Now this is done, this part is done. Now let's try to put sensor at this position, because this sensor cannot sense here. Distance is 2, 1 comma 2, but your distance should be 1, and this also cannot be done here. So now what we'll be doing is, again this is your starting point, you will go k distance down diagonally and will place it here. So this sensor can sense up to this much distance, this area it can sense, this sensor it was sensing this area, and this sensor cannot sense here. So again you will move at this location and try to find the try to place the sensor. So again one distance diagonally you will move and you will place it here. So basically in this example you will be placing only 4 sensors. So this is the idea in order to solve this. So and I think how can you solve this, since k is 1, and what is this area that is covered by one sensor when k is 1? When k is 1, it is covering 1 2 3 distance and 1 2 3 distance, like it is covering 9 cells. So can we call this length and breadth can be 2k plus 1? So yes, it is. Like if you put k is equal to 1 here, it will be 3. So 3 distance is covering and 3 distance it is covering. So now for a given, this is basically m columns and this is n rows. So for a given m columns, uh, how many sensor you can put. So in order to answer that question, that will be basically, you will have to divide every m, this is m number of columns, you will have to divide with 2k plus 1. If you divide with 2k plus 1, so we will get to know how many sensor you can place. But since here your m is 4, I mean m is 5 and 2k plus 1 is 3, so it will give you 1 because it is an integer division. So but like in this particular area, you're placing two sensors, so you'll have to check one more thing. If m modulo 2k plus 1 is having some reminder, which means there are some of the areas which are not covered by like one sensor what you have placed. Okay, so in order to cover that area, you will be placing one more sensor. So in this case you can place, like this is the remaining area, right? So in this case you can place sensor here as well. So if you place sensor here as well, it is sensing like here. So basically what I'm trying to say is, the remaining area whatever you have which is not sensed by the uh, these sensors, like m divided by 2k plus 1, so that in that area you can place one sensor. And that's why your answer now, since it is 1 and here you have got reminder as greater than 0, again one more sensor you can place. So basically in column side you can place two sensors. So in the same way, you can try to find out how many sensors you can play downside. So that is basically n number of rows are there. So how many you can place? So it will be given by n divided by 2k plus 1. So here n is again 5 and divided by this is 3, which is 1. But if you see, you are placing in the row two sensors, right? So in column you have placed 2, in the row you are placing 2 sensors. So but by this you are getting 1. So again you do the same thing, n modulo 2k plus 1. So now again it is like n modulo 2k plus 1, if you do, it is 5 modulo 3, so you will get 2. So whenever it has greater than 0 value, so one more sensor will be placing. So in the row side, again you will be placing 2 sensors. So now how many sensor in total, like 2 sensors you have played in this position and 2 sensors you have played in this position. And since if you multiply column into row, it is 2 into 2 into 2, which is 4, like 4 sensors overall you will be placing. So let me take one more big example so that you will understand like why it is row into column. Answer is row into column. Row into column means row is basically given by this formula, column is given by this formula. So let me take n as some 7, yeah, and m is also 7, let me take, and again k is equals to 1 only I'll be taking. Okay, again sin, we have 0th row, 6th row, 6th column. So when k is 1, so you will be basically going diagonally 1 and you will be placing here. So this sensor can cover up to this positions. Again you will be moving forward and you can place sensor here. So this will be covering this much area. So 2 sensors are placed. So this one is not covered by these 2 sensors. So you will be placing 1 sensor extra and this sensor can cover all the distance. So now when you move down, you will be placing at this position the sensors. So it is covering up to here area, right? In the same way you will be placing here. So it is covering up to this area. So here we don't have, you will be placing at this position. And since this area is not covered by any sensors, so you will be placing one at this position, and this sensor can cover up to this much area, and this sensor can cover up to this area, and this area is not covered by anything, so you will be placing one more sensor here. So this is one of the optimal solution. So now like 9 sensors will be placing. Now if you try to find it row, like how many sensors you will be placing in the row, that is given by n divided by 2k plus 1. What is n? N is 7. What is 2k plus 1? Which is 3. So you are getting s2. But when you do modulo, one more, because 7 modulo 3 is 1 modulo, so one more answer you are getting. Basically 3 is the answer. In order to find column, that is again 7 by 3, which is 2, but 7 modulo 3 is it is giving remainder greater than 0, which means it has some area. So in that we'll have to place the sensor. Now if you do row into column, so basically 9 sensors you will be placing, which is correct as shown in the diagram. But if you do 3 plus 3, it is not. So basically how many sensors will be placing at this position and at this position. So into these two, if you do, all like sensor will be placing in the grid. So I think you guys got to know how to solve this. Let me just try to code it up. So what I'll be doing is I'll be taking int sensors row, basically sensor in rows. So it is like n divided by 2k plus 1. Let me take one int denom, which is basically denominator, which is 2 star k plus 1. So every time I'll not be writing 2k plus 1, 2 star k plus 1, so I'll be writing denom. So this is number of sensor. If we find that n modulo denom has some value, which means your sensors in row will be increased by 1. Now let's take int sensors in column. So it will be m divided by denom, and if we find that m modulo denom has some sensors, I mean has a remainder, some remainder which is greater than 0, so your sensors column will be increased by 1, and at the end you will have to return sensors row star sensors column. Let's try to run the code. Let's try to submit it. Yeah, it got submitted and it beats 100% of the user, because here the time and space complexity both are constant. We are not using any for loop, we are not using any extra space. So I think you guys have understood the problem, and if you did, so do like the video and share it. So yeah, thank you guys for watching the video.